So it's Sunday, and we did do a church service via Zoom from my church pipe organ restoration workshop. I don't know what YouTube did with the sound for the last 15 minutes of yesterday's video on the audio line 342. Unfortunately, I erased the master because I'd had a feedback from YouTube that it had gone through. So, and I was using the memory card for something else, unfortunately. So. I'll try and look at what YouTube's done with it in future. So, when Bedford Dave came over, he passed a couple of sets on for me to keep, and one of them is a Team TS8000 with no front bezel, but with the factory mic, and the other is a Baby Midland something or other with no front bezel either. There must be a place in the person who gave them to Bedford Dave, must be a place where front bits of radios end up. But it's greatly appreciated, however complete. So, if I remember rightly, these are an 80 channel set under PR2797. So it's the TS8000. We've got a circuit diagram for the 4000. Don't know whether that is anything to do with it whatsoever. We've done one of these before, somewhere down the line. It's a pluggable speaker, but I think there's enough wire for us not to have to unplug this one. Oh, I don't know. We'll unplug it. Better put the soldering iron on because I can see there's lots of cores with wax in it. I seem to recall these one of these sets that if you get them to do anything near 4 watts, they get very, very hot. So when you've got bars out of the display, not surprising when you've got no bezel on it, it's usually indicative of there being dirt between the connector and the display, which can be a bit of a faff to try and do. So that's 9. That's 19. Obviously that's 20. I may look into that, but we'll see if we can get the radio to work at all. It's one of these which has an S-meter socket on the back. Somebody asked me, where do you get those external S-meters from? And I noticed that Knights at Curtin and Lindsay have got them for $49.99. Remember, they're just an S-meter. It's a meter in a box. It's not. It doesn't do anything else but be an S meter. It's not an RF meter because a lot of CBs don't have circuitry for an RF measurement thing. It's just a fake bar graph. So when we press transmit on this, my goodness, it does. It transmits, and we have a bar graph on this. And it's on UK channels. So straight away I can see that we're going to have transmit down that line. Could be a one under there, in which case it'll be the 54 meg trap. Then we're going to have a receive down this line. That capacitor has a bulge in it, so I have to take the bottom lid off and deal with that. It may have been overvolted, because these are going to be now 20 years old. It says signal on the mic. Is that the call tone? Let's get our monitor receiver on. It is. Tell you what, that might make setting up the deviation really easy. Right. It's a rather sophisticated looking processor there. And some hot spots. Right, I'm going to turn the power off. I'll get that unsoldered. It's not always obvious. Oh, where's the end of my solder sucker gone? Thought we got a printed circuit board crack there, and we haven't. It's a bit of hair. Could be from brushing solvent cleaner on it at some point. The printed circuit board says TS8000 UK on there. Right, I'm going to have to go to pinch a solder sucker off Mr. Chippy's bench. Okay, having pinched Mr. Chippy's solder sucker, whilst he's not looking. So I've taken out the capacitor, and the shaded part indicates the negative on this printed circuit board. Now when we look at the component in question, start to see the heat shrink has come away. It's 470 microfarads at 16 volts. Plus I could see that it was starting to bulge. We'll put a nice new one in. In fact, I'll tell you what we'll do. We'll test the new one. So it should be 470 microfarads. That's brand new. It's 500. That's fine. And we want negative to the shaded bit. I've gone and left the solder. Somebody wanted to know what make and part number of solder we use, which is an RS one, and I've gone and left it by the computer. So we've got a little sliver of solder kicking around on the bench. Which we will use. So now what we'll do is we'll measure the one that I took out. Well, there you go, it's short circuit. That wouldn't have helped the radio, would it? So that's today's visual inspection. So it's going to be one of these that disconnects itself from our crocodile clips constantly. I think with the cold it's made the wiring quite stiff. Okay. Switch picture in picture on, and then you can see what I can see of the test instruments. So straight away we've got a good 3 watts, about 3.1. If I remember rightly, this preset is transmit power. But then again, I could be very, very wrong. The circuit diagram doesn't show presets. It just says VR this, VR that, VR the other for variable resistor, instead of showing it as a preset. It doesn't on the circuit. Deviation. Yeah, I could have sworn on a stack of Bibles there was a preset power in these. Yeah, it's that one. It's that one just there. Okay. Probably about 3.5 watts. To make sure that's not over the top on power. As I've said before, you can get these to a position where it makes no difference. So we can turn it down, we can turn it up, but there's a point at which it makes no difference. So we want it where it just makes a difference, otherwise we're going to be thrashing it. So I wonder if that preset is for if it's got an RF meter. It certainly hasn't with that. I don't care what I mess with, that's probably Squelch. Let's say that's that one there is going to be deviation, I think. You know what, it's not, it's the meter. So at the moment I've got that set at 4 and the radio's doing about 3.5. So we've got power and we've got RF meter. So let's have a look at deviation. which I'm bound to have upset. So 1.5 at the moment. So is it that? I doubt it. Is it that? I doubt that as well. So is it that one in the naughty corner? It is, it's that one. That's a bit dirty, so we'll just give it a quick spray. So with it at full, we've got 2. Wallow. So we'll get about 2.15 maximum out of it. It's a little quieter than what we'd like, but that's the maximum it will do. That's still better than... So I hadn't messed with that one because I hadn't seen it under that bit of paper. So far, transmit power, deviation, and RF output meter. So now we'll look at transmit frequency. So just move the camera across, wrong camera. Let's move the correct camera across, wrong camera, and the other correct camera across. Should be 2779125. It's 2779121 toggling 2, and the trimmer for that is just there. It doesn't really need touching, but just for the demonstration. So we've got toggling 4, 5. That's spot on. That was pretty spot on. That was. I mean, that'd have to be about 80 out for it to make any difference. Right, we'll move that back. Good. So that's a jolly good start. So what about receive? So we'll just dial in 2779125. We're listening to 0.3 of a microvolt, so that's very good sensitivity. And we'll just pop the camera onto the oscilloscope. See if we can find a detector. So I'd like to think that's the detector. It has a crystal filter, which is unexpected. So what we're looking at, we'll put an S9 signal on the radio, which is 100 microvolts, and there we go. We're going to look for maximum recovered audio. It's not that one. It's actually that one. Good. Whilst we've got S9, see if we can find the meter preset if it has one. We've got 135. So What could we have? It could be that one. But it isn't. Could be that one, which it isn't. Could be that one, which it isn't. So it makes me wonder, is it this one at the front, which is used for both transmit and receive? No, so we'll now need to reset that on transmit. Let's reset that. Well, that's caught me out, hasn't it? See, these are around the kind of part of the circuit. So it's definitely not that. I've moved it again. It's not that. It is, it's that one. It was just slow to respond. So we've got transmit meter, we've got receive meter. So we're going to have squelch and auto squelch, or preset squelch. That's what's going to be left there. Okay. So we'll move this up now onto the synad meter, and we'll turn the attenuator down till we get about 4 decibels. I'm actually wasting my time because it's spot on, but just for the demonstration. And I'm tuning this for UK 40 despite it being an 80 channel set, because I want it to work best on UK 40, seeing as it's my set. So we know that's the detector. Okay, we'll just put a bit more signal on. So I'm looking at the oscilloscope and the it's about optimum, and the synad meter. I'll just put a bit more signal on. That's optimum. Just check again. Yeah, it's one of these you need more signal on. They don't have this kind of time at the factory, you know, once it's set at minimum amount, out the set's going to go. So see what we've got. So 10 dB synad, 12 dB synad, 20 dB synad. Doing it the other way around today. So it's doing 20, not all sets do because of noisy transistors. And actually it's quite incredible that it's 0.85 of a microvolt. So ready mate only does 3.5 watts, but it certainly makes up for his on receive. 12 dB. We're at that point where I'm between scales. We'll say 0.3, and then 10 dB, .27. So very sensitive. So let's look at the squelch. We'll turn that to full. And then I'll move this camera so you can see the attenuator. It seems to be I've got that sticky bit of paper stuck to my fingers. So we've got that parked at 0, 10, 30, 100. That's when I want it to come in. So we've got two possible squelch presets. I'll go for that one first. Want it to just come in. There we go. And now at 30 microvolts it's gone off, so that's great. So we'll check the minimum sensitivity. So I'm going to switch the signal generator off. That's set threshold on the radio. Switch the signal generator back on. Not that sensitive. 0.18 of a... Sorry, 1.8 microvolts. Let's just see if we can set it better than that. Just try again. We'll just set threshold again. Coming in at 0.41 of a microvolt, and it's disappearing off at 0.16 of a microvolt. 0.41 on 0.16 off, so that's fair enough. It's pretty finicky to set that control as finely as that. So now we'll look at the auto squelch. So switch that on, see where it comes in at the moment. It's coming in at 3, it's leaving us when. We'll just, because we've messed with that, yes, that's definitely the preset for it. So we'll set that. It's coming in at 0.9 of a microvolt. And it's leaving at point... Actually needs to be a bit stronger than that. That's better. So now it's about 1.4. I'll just turn it up a bit more. That's better. 1.9 microvolts to come in and 0.9 to leave. So that's set up nicely. You don't want it too sensitive because you're going to switch to auto squelch when you when you drive through a town, and you get all that interference from Wi-Fi and petrol stations and that. So there we go. So it was just to recap, and you could wind this back. We've got transmit power, we've got the preset squelch or the auto squelch, which is the switched position. We've got the normal squelch, we've got the S meter, we've got the RF meter, it actually has one, and we've got deviation there. And then that one was the detector. So that was your transmit strip, that was the receive. And it does have scan. So if I turn the signal generator up, there we go, it stopped on channel 20. And then if we switch that to EU, it's in 3.1 watts and it's on channel. Switch it to UK where I've optimized it, and it's doing 3.5 watts. I'll see if there's anything I can do with that display. And it's a 2, 4, 6 pin mic. So I'll pause the video. Okay, so I've put it together. It was decided not to do the display. It would have meant taking the control potentiometers off, and they're exceedingly recessed nuts right down there, which we just don't have a tool to do. I don't know anybody who does have a tool to do apart from the factory put it together. So it really doesn't matter. We know what channel it's on. Switch it back on. It's now on an aerial. Boots up on channel 9. Press scan, see if anything on. Go over to EU. It says EU in the window. Scan. Back to UK. I think there's a bit of chunter there on channel 9. So go out to scan and then move it up with the mic. That's 19. One nano, Roger. Okay, so we'll do an on-the-air test with that, and it's going to work all right. 3.5 watts output. It came in at 3.2, so we improved that a little bit. I've found in my experience that they do get rather hot even doing that. They're not a really heavy-duty set. They don't have exactly brilliant build quality, but I tell you what, it's receiving fine. And there you have it, the Team TS8000 8000. These were about 1990. They'd be 1997, wouldn't they, to be with that approval. So we'll do an on-the-air test later on, and a bit of a repair there because of that capacitor. Thank you for watching.